This group project by Mary McClung,
Robin Grissom,
Andy Ryman,
Amber James,
Hannah Mullis,
seeks to investigate local density in galaxies. We wanted to know what's the relationship between type of galaxy and local galaxy density. Our first hypothesis is elliptical galaxies are more isolated from other galaxies, and our second hypothesis is spiral galaxies are surrounded by more galaxies than elliptical. Remember that elliptical galaxies tend to be red and older, where spirals tend to be blue and younger. Through observation of galaxy data and critical thought, we were able to extrapolate the following. We separated the data from the original data set by the local density with G minus R is greater than 0.6, and local density with G minus R is less than 0.6. We then analyzed the histograms and statistics for the two separated groups of data and compared that result.
We then separated the galaxies from the original dataset with near cluster distance G minus R greater than 0.6 and near cluster distance G minus R less than 0.6. We then analyzed the histograms and statistics for the two groups of data and compared those results. We noticed that there were a large number of outliers in this dataset that did not have a distance to a near cluster. We decided to take out these outliers by changing the formula we structured the data with to near cluster distance greater than negative 999 with G minus R greater than 0.6 and near cluster distance less than negative 999 with G minus R less than 0.6. We then analyzed the histograms and statistics for those two separate groups of data and compared those results. We finally separated the galaxies from the original dataset by location density with elliptical greater than 0.8 galaxies and local density with spiral greater than 0.8. We then analyzed the histograms and statistics for these two separate groups of data and compared those results. We created and decided to use histograms for the data of the local density with GR greater than 0.6 and local density GR less than 0.6. These graphs show that there is a right-skewed correlation between local density and the color of galaxies.
We also created histograms for data on local densities with ellipticals greater than 0.8 and histograms for local densities with spirals greater than 0.8. This showed that there is a right-skewed correlation between local densities and the kinds of galaxies. We then used the stats of the separated data to better show the differences in the local densities with ellipticals greater than 0.8, local densities with spirals greater than 0.8, near cluster distance greater than negative 999 with G-R greater than 0.6, near cluster densities greater than negative 999 with G-R less than 0.6, local densities with G-R greater than 0.6, and local densities with G-R less than 0.6. For our source, we discovered a journal article titled The Importance of Local Densities in Shaping the Galaxy's Stellar Mass Functions from the Royal Astronomical Society. In their article, they discussed their findings of a weak correlation between stellar mass and environmental at intermediate redshifts. The article continued, the color distribution is not strongly dependent on environment of all mass ranges, exhibiting only a weak trend such that galaxies in overdense regions are redder than galaxies in underdense regions.
The graph included on this slide shows that the color of a galaxy is not strongly influenced on the environment around it. This is important because some of our results and graphs rely on the color of galaxies being independent from their surroundings. The data shows that the average local density of blue galaxies is lower than the average local density of red galaxies. The data also shows that the average local density of elliptical galaxies is greater than the average local density of spiral galaxies. The data for the near cluster density shows that the average blue galaxies tend to be greater than the average red galaxies. We wanted to know if the galaxy's density had anything to do with its age, and we found that the younger ones tended to be closer to the other galaxies. We noticed that the younger galaxies are still forming, allowing them to interact with other galaxies in the environment. Also, the older galaxies are the majority of mergers and galaxies dying out. Our evidence led us to the conclusion that the spiral galaxies, on average, have a lower local density. This means that they are closer to other galaxies. Blue galaxies tend to have a lower local density.
We assumed that elliptical galaxies would be more isolated from other galaxies, and that ellipticals were red and older. We feel secure in our assumptions because they were supported by our conclusions. Based on the information we uncovered, we are left with one unanswered question. Does the cluster density of local galaxies affect the proportion of heavy metals within the galaxies? Only another group project will know. Through our interactions with Astronomy 103 and the nature of science and data, our team has discovered a couple of things. Firstly, it is very easy to confuse what exactly your evidence is telling you when you do not double-check your information. Secondly, things may seem plausible at first, but the more you learn, the more you realize that your beliefs are not always accurate. It is important to question the things you think you know and be ready to find the answers you are not expecting.